Okay, testing the mic. Okay, this is Stephen Smith. It is about 8:45 on September 23rd, 2018. This is I'm making this recording because we're missing something here in modules 3 and 4. I'm referring to module 3 and 4. I'm going to module 3, page 4, guided practice. I'm going to use as an example. Now, in this example, we're going to create two tables. This is just like the one I asked you to do in the exercise. I'm sending an awful lot of them back. They're just not right. Doctors and patients. Okay, this is just like you're creating owners and pets. A doctor has a unique identifier, a name, an address, city, street, city, and state. Do not put all of those into one field. Okay, that's 3 fields: a street, a city, a state. They have a phone number, and here's the important one: 0 or more patients. One doctor has many patients. Okay, that's a key word. That's a buzzword that you're looking for. One doctor, a doctor has 0 or more patients. 0 or more patients. That is the one side. That is the parent table. Okay. Now that's important. You got to look for that because that's the way it's going to appear to you on the test. 0 or more something. A car is serviced by 0 or more manuals. A manual applies to exactly one car. A patient has a unique identifier. That might be social security number. It just might be an ID. I don't know. A name, an address, street, city, state. Do not cram them all into one. And exactly one doctor. The one side, the child side. 0 or more is the parent. Exactly 1 is the child. Okay? So which side is the many side? The patients, the one that has exactly 1, because one doctor has many patients. Do you see that? A doctor has many patients. A patient has exactly 1 doctor. Thus, we have a one-to-many relationship. Open a file in your text editor and write the program to run it. And I'm going to go pull up that program now. And we'll talk about it. But do you see the one side of the relationship and the many side of the relationship? The many side says exactly 1. That means the one side. That's the many side. One patient has exactly 1 doctor. A doctor has 0 or more. Which side is the one side? Which side is the parent? The doctor is the parent. He has 0 or more patients. Which side is the child? The patient is the child. They have exactly 1 parent. You have to be able to spot that. A lot of you are getting it backwards. Okay, let's go over here. Didn't tell you what the database you had to name your database. Change this if you need to. Okay, the first thing we're going to do, a lot of you are not doing this, we have to drop the table. So if object ID patients is not null, drop table patients. The patients table gets dropped first, because if you dropped doctors, that's the parent, and the child table would then be left with invalid references, and we cannot tolerate that. So we always have to drop the many side first, drop the child first. In the case of the pets and the owners, which one gets dropped first? Well, pets, because that's the many side. Then after that, we can drop the one side, the parent side. When I create a table, I will bracket that with go. So I create the table, I have the go before I start creating the table. I don't have to put go between them. I don't have to put go up here. I put go before I do a create. The last thing that happens before I create, I have go. This is a SQL Server thing. Or worry. Whether it takes a semicolon or not, I don't worry about it because that's SQL Server and it doesn't really matter. But this is an SQL statement. This will run in any of them. Create table doctors. and I have my SD, Dr. SSN, my doctor's name, doctor's street, city, state, phone. I avoid having a blank line inside of the create statement. I don't care about out here. Constraint doctor's PK is a primary key. We always name the constraints. Why? Because if I violate that constraint, I will at least see the constraint name in the error message. Sometimes they can get pretty cryptic. Here's a constraint for checking that the name is not null. No comma goes at the very end. SQL Server will let you get away with it, I think, but most SQL won't, so don't put a comma there. Okay, now on this one, between them, we have go. Why? Because here is a create statement, here is another one. This create statement is bracketed by go. Here's the go that opens it. There's the go that closes it. It's a program all of itself. Now we have a new program, create table patients. Now here's where it gets a little tricky. I have a patient unique identifier, SSN, or ID if you like, name, street, city, state. Now here's the key. Here's what makes it all work. The many side gets a copy of the primary key from the one side. In my opinion, it should be named the same. It must be the same type. It should be named the same. It must be named the same type. The foreign key goes in the many side. Lots of you are getting it. One patient has many doctors and doctor has many patients. Here's the primary key constraint. Here's the foreign key constraint. Okay. Let's see, exactly one doctor. This one needs one more, excuse me, comma. This one needs constraint. I'm going to call this constraint no orphan patients, meaning that the patients have to have okay, so I'm checking that this DSSN, the one in the child table, the one in the many side, the one in the patients table, they're both named the same. The DSSN here in the patients table is not null. It can be null and still be a foreign key. It won't hurt the foreign key. A primary key cannot be null. A foreign key can be null unless I constrain it. If the foreign key were null, then that would mean that a patient had 0 doctors. And we said that the patient had to have exactly 1 doctor. We're going to insert into the doctors first. Okay, insert into doctors. We have to have the field list to be correct. If you don't have the field list, and you do it in exactly this order, and you have all of them in there in that order, it will work, but I will not be happy with it. I want to see a field list, please. If you have a field list, you're a lot more flexible, meaning I can or mix them and match them, change it any way I like, or arrange it any way I like, as long as this list matches this list. Values, the doctor's SSN is 1, 2, 3, 4. The doctor's name is Bob. Doctor's street is 1, 2, 3, 4th Street. The doctor lives in Plano, Texas, and there is the doctor's phone. Fairly straightforward. Note that they're all in quotes. And here's it gets a little tricky and certain to patients. Now, notice I have the doctor SSN. I usually put that one at the end, but you don't have to. You could put it right after PSSN if you wanted to, but I always put it at the end like that. This patient's SSN is 9867. This patient's name is Joe. He lives at 234 5th Street in Denton, Texas. Now, here we go. His doctor is Who? The doctor with DSSN 1234. This takes us to the other table, 1234. This doctor's name is Bob. Okay. Now, must match. I don't want to see this field being left empty. When you do the inserts, put this field in there. So if I say that Joe's doctor is Bob, you have to go up here and find that primary key and put that primary key in there. I can't put Bob in there. Always execute the code. Oops, something is wrong. Something is dreadfully wrong, for I feel. What is this? Line 57, go find it. Do not turn in a program that had, oh, I'm sorry, I had it highlighted. That's the problem. Execute. Notice that it executed now. You can't execute something if you highlight something, it'll try just to execute 34, and it can't do that. Always highlight, always check it. Do not turn in something that doesn't run. Always run it a couple of times. Check it and check it and check it. If you get these, it's very common to get these guys. Students will frequently get them out of order. Like that, they'll try to drop the doctor's table first, then drop the patient's table. This is very common. I saw a lot of these. Execute this, and I get an error message. Do not turn in a program that has an error message in it. It's just going to come back to you. Okay. Why is that? I cannot drop doctors because it is referenced by a foreign key constraint. That's the big one. The rest of these don't worry about. They'll go away when you fix this first one. Cannot drop doctors because it is referenced by a foreign key constraint. This is because there's a foreign key in patients that is referencing doctors. I cannot drop doctors until after I drop patients. Now it will run, execute. Make sure you execute it twice, because what would happen if I had it in the wrong place? Let's put it back in the wrong. I'm going to make a mistake now. But what would happen if I went over to the Object Explorer? I need to refresh it. Tables. And there's my doctor's tape. Let's see, there's the patient's table, and I'll delete it. And the doctor's page, I delete him. And now I come back. Remember, I have deleted these two guys. Okay, so doctors doesn't exist, patients doesn't exist. Now it will run just fine the first time. But when I try to run it the second time, it won't run. Okay, make sure it runs time after time. The only way to get that is to drop the patient, drop the mini side first, drop the child first. How do I know it's a child? I look at it and it says if a parent has 0 or more children. A parent can have many children, 0 or more children. A child has exactly one parent. I could say at most one. In that case, we would be allowing orphans. So I'm going to hope that you get the idea that the owners are the parents and pets are the child. Therefore, the pets have to be dropped first, then the owners. The owners are created first, then the pets. Then you insert into the owners. You insert into the pets, and the owners' primary key, whether you call it ID or SSN, I don't really care, goes into the pets table. Okay? This guy is this guided practice one is found on Module 3, page 4, and I guess I could send this out as an example. So I could present this. I'll save this and attach it to an announcement where I announce this recording being posted. So with that, I'm going to end the recording. Stopping the recording now.